Thank you. Yes. Thanks for coming back if you did, or sticking around if you did that as well. I think probably I have enough buzzwords in the title of this talk that I at least snagged some of you that way, so hopefully you won't be too disappointed. I guess I should say who I am first. My name is Carson Farmer. I work at the CARSI lab in New York City, part of the CUNY University system there. And we do stuff with spatial data, mostly. And this is sort of an experiment that a colleague of mine and I decided to try out. And for the most part, we're pretty pleased with the results. So I'll kind of go through what we did, why we did it, and then mainly talk about the Python packages that we cobbled together to do this. So I'll start by using a couple slides that I basically just pull out of NSF grants that I put in with buzzwords and things like that, and then I'll get into the more interesting Python stuff. So, there's all these new social media information sources which potentially we can gather information from if, they don't decide to stop providing APIs and things like that. And so we decided can we take some of this information and potentially figure out what people are doing, where they're doing it, and hopefully I'm a social scientist, so hopefully provide information for planners and other social scientists to actually, work on policy decisions or implement things like that. And then maybe if along the way, it turns out to work well and we can, make a little spin-off and make some money, that would be cool too. So the kind of idea is people walk around tweeting, probably walking into things and saying what they're doing, are leaving behind all these sort of digital traces, right? This is a little art piece to kind of represent that. And we want to be able to harness that and potentially answer some questions about where people are going and things like that. So the whole point is we want to be able to tell, say, planners or other social scientists what is going on and when and where that thing is happening. Okay, and the whole point is we want to be able to do this kind of without knowing necessarily what we're looking for. And so the idea is, can we extract some information from different types of digital data sources? And on top of this, a colleague of mine and I, we recently wrote a manifesto for GI Science, which about doing streaming GI Science. So the idea is, big data is you have to scale everything up, blah blah blah. So why not just not store things and just do things as they come, keep things nice and lightweight. And so I haven't actually done any streaming GIS yet. So I thought, well, if I'm going to write this paper, I should probably also try to do it. So here's our attempt to do that. So we decided, okay, first of all, we're a small university institution, so we can't afford these giant, big database systems. So let's just forget that, and we'll just do things in real time. We'll keep it super lightweight, which is why I love Python, and we'll develop this kind of streaming data analysis framework. So the goal here is basically take a little bit of Python. You could grab like a little Anaconda's installation, chuck it on pretty much any server anywhere, and do some of this analysis and get some results and be able to look at it and share some of this information with people. So hopefully we can do that. And then the whole point is, ideally we want to be able to pinpoint some of these sort of exciting digital events, or not necessarily digital events, exciting events using digital information. So another little art piece there. Okay, so that's the sort of quick introduction to what and why we're doing it. What we're doing is cobbling together a bunch of different Python packages to do all this stuff without having to write our own Python package on top of it, basically. So we start by, we're going to use Twitter because that's pretty easy to get. So we start by just streaming in Twitter feeds from a particular location, and the examples here I'm using are for San Francisco. Run some online latent semantic, some kind of information discovery routines. In this case, we're doing latent semantic analysis on the tweet content, so what people are talking about. Okay, and in this particular case, we're just collecting geolocated tweets so that we have the spatial information. We are not extracting geographic information from the tweets. We'll let other people figure that stuff out. And then basically what we do is we create grids of these geolocated tweets on a particular topic or with particular semantic information. We run a kind of super efficient kernel density estimation approximation so that we can get basically densities of various different Twitter topics. Normalize that for population, because if you don't do that, you're just going to always identify population clusters, which we can do already. And then we identify the high density areas, tag them with the, hopefully semantically tag them with some of the topics that are associated, or the words that are associated with a particular topic, and then feedback those results again in real time to planners or whoever happens to be wanting to do this type of thing. And every single one of these packages has to support this streaming framework. There can be no batch operations whatsoever. So everything has to process the data as it comes to it and output something that can then be streamed by the next package or the next piece of data analysis. And so that's kind of the whole point of all these things. So some parts of this are really easy, and some parts are very hard, and we're still kind of tweaking it and figuring things out. And so I'll kind of go through each package and talk about how we did it. So the Twitter part is actually by far the easiest part. And in fact, this code right here is pretty much the entirety of the code required to stream Twitter data for a particular location. So that's pretty cool. And really, you only need to implement the onData method here, and then this do something awesome with the tweet info is, that's where you put your analysis. So that part's easy, and I'll put these slides up on later, so if you want to click on that link, then you can also have your own Twitter streaming application. So that's very easy, and as you can see, we do not actually there's no sort of importing some database or anything like that. We never ever store the tweets themselves at any point. Okay, we just pull them in, do stuff with them, and maybe store some results if we want to keep them. Okay, so the text processing stuff, that's not easy. Okay, that mainly because I come from a sort of spatial stats geocomputation background, so I really don't know that much about this stuff in the first place. So for the people who do know about this stuff, ask me questions in private afterwards, not in front of everyone. Okay. But yeah, so we do some of this, and in case you don't know what latent semantic analysis is, it's kind of the whole point is kind of ideas that are close in meaning are probably going to occur in the same document. And with tweets, it's a pretty good assumption actually, because people are usually, you've only have 140 characters, so you're really only going to tweet about a single topic. And it's very interesting the topics that people do tweet about. So I'll talk a little bit about that later as well. And San Francisco seems to be even weirder about what they tweet about. So that's pretty good. We use this really cool package called GenSim, which has all sorts of online or streaming APIs for doing latent semantic analysis, including some Bayesian versions, which are pretty cool and require very little parameterization. And there's a few things we have to worry about. So we have to tokenize the tweets. So we have to pull out like little bits and pieces, like the different words, and for this work we're not really ascribing meaning or like sentiment to any of the words. We don't really care what they mean. We just want to see, okay, is this particular topic made up of these particular words? But there's a few stop words that we use, and I'll talk a little bit about why some of them became really important to use, particularly for the Twitter example. And then actually there's the group who's behind Twitter natural language processing. They've got this tokenizer, which they call Twokenizer, Twitter tokenizer, pretty clever, right? And it's really cool because it's optimized for like 140 character Twitter type language. And it includes tokens for all of the weird emoticons that people use in Twitter. And which is, very cool because you've got 140 characters, but a smiley face means, an entire concept which you can fit into 3 characters. And so we want to be able to get that information. A smiley face should not be dropped out of the analysis. It really is part of a particular topic. Okay, so it's possible that through this analysis that we do, we may say there's like a smiley face happening here, and that probably means there's a bunch of people who are really happy or something like that. So we need to use tools that are available to actually work with Twitter data, and luckily there's Python packages to do it. So this is actually a Python port. It was a Python library first that was ported to Scala, that was then ported to C++, which was then ported to something else, and then back to Python again. So they, eventually they finished it correctly, but along the way there were some mistakes, I think. Anyway, we use a pretty simple bag of words representation for our document vectors, which pretty much basically is you just take account of how many times each word occurs in a document. And it's a pretty simple sort of way to represent it. You can use term frequency. So instead of just the number of counts, you can look at like overall how often that word occurs over several documents and things like that. But it actually works fairly well just using a bag of words representation. And then the other cool thing is because these are online streaming algorithms, you can specify a decay so that over time the topic extraction sort of forgets old topics. And so for something like the internet, whose attention span is, I don't know, probably about 45 minutes, if we kind of turn that decay quite high, then topics will get forgotten as new ones come in. And that doesn't affect the topic extraction at all. So there's no problem with adding new documents about completely new topics. New topics will appear, old ones will fall away, and we can handle that fairly easily, which is pretty cool. And yeah, there's other ways to speed this up, but again, I don't really know that much about topic analysis, so I'm happy to use some of the sort of more standard, well-tested versions. So that's pretty cool. The gridding topic counts part is great. So basically, we throw the documents as they come into the LDA or LSA, and we pull out topics, which we don't know what they are, but they've got some associated words. And what we basically do is we create a grid of where the tweets of a particular topic occur, right? And so we may pick the first, the 100 most popular topics and create a separate grid for each of those topics, okay? And the easiest way we found to do that is basically take the coordinates for those tweets, geohash them. Anybody familiar with what geohashing is? Basically, like, create a hash of the two coordinates. And the cool thing is that points that are close to each other are going to have very similar hashes. And so what you can do is you can hash the coordinates, and then you can chop off the back end to sort of reduce the precision of the coordinates, and then convert them back to points. And now you've got basically a gridded set of points. It's very simple, and it's actually really, really fast to do. And there's some really fast C libraries for geohashing and going back. So that's pretty cool. So you just kind of hash and back. And then you just count the number of unique topics at each one of those grid cells, and you normalize them by the total all the tweets that occur there. So you can kind of you just keep a running total of how many tweets are happening overall. So that's pretty easy. It's very important to do that normalization. Again, otherwise you just get population density, which isn't that exciting. And there's a great XKCD comic about that if you're into that sort of thing. And then we just do kernel density estimation on top of that. So we've got essentially what we have is a 2D histogram of counts for a particular topic. And we just do KDE on that. Well, we just do a convolution of a Gaussian kernel with this 2D histogram. And that is like lightning fast. Really cool. SciPy makes this so fast. We do not use Gaussian KDE or any actual kernel density estimator. We just do an approximation. The results are almost identical every time, and it's probably like several orders of magnitude faster than actually doing a kernel density estimate, and you just don't need it. So that's pretty cool. We can handle, I can handle billions of points, or about 1 billion points, really quickly. You just stream them through and then do the convolution afterwards. So the convolution is only ever on the little grid that you've counted up, which is great. Of course, we never need to do 1 billion points because we're streaming things in. So it's not that hard anyway. So the cool thing is you just stream the tweets in the to count up the 2D histogram, and then when you need a density estimate, you just run the convolution right then and there. So you never actually need to do anything ahead of time. The other thing that's kind of cool is that you can do a weighted kernel density estimate, and then you just use the actual weights for the various words that are associated with a particular topic. So you can actually do weighted kernel density estimate or estimation to get some sort of more nuanced density estimates for your particular topic. So that's pretty fun as well. Okay, and then so right now we are basically identifying these topics and letting letting users, right now that's just me, browse for particular topics to visualize the densities. Eventually we're going to try and automate it so that it'll just pick a particularly hot topic and zoom to a particular location and you can see what's going on, that sort of thing. The really important thing is getting the scale right. And so right now we're trying to focus on city scale. And I've got a couple figures where the scale is not right. And as you can see, it really provides very little insight. So getting that right is hard, and we haven't quite figured that out yet. There's quite a few algorithms we can use to try and estimate what the bandwidth for the kernel density estimator should be and things like that, which help to figure out what scale to work at, but that's still kind of a tricky one. So here, I don't know if anybody remembers Bat Kid. This is something that happened a while back in San Francisco. And so this is a sort of density surface of tweets about #BatKid, which happened in San Francisco. Okay, we all know that it happened in San Francisco, so it doesn't really tell us very much information about exactly what was going on. I have a figure in a little bit that shows you exactly where people were standing, potentially, when they were tweeting about BatKid. But then you have more general concepts like concert, where you have venues where there's lots of people going to a particular concert. So there's some in San Jose, some in San Francisco, and some in Oakland. This is aggregated over multiple time periods instead of breaking it up into specific concert events. But what we found was actually you could find specific concerts as well. So there was a Drake conference or concert. I'm not sure who this guy is, but I guess he is an artist. Anyway, so the concert was happening up in Oakland, and there was obviously people from San Jose going to the conference, or concert.
So they start at the bottom, right?
And now they're here. Yeah. Okay, that's him. That was good. Thank you. I'm going to use that next time. Started from the bottom. Now they're there, and but we would identify the concert in Oakland as the location of the event, not San Jose, because it's a higher density of tweets there, right? So some ground truthing needs to be done, but still working on that. Okay, so then the last part of all this is to actually send feedback information to whoever, the analyst or whoever is interested in what's going on. And again, this has to be streaming as well. So we use this really cool package called Pico, which my colleague is the developer for. And it's just a really super lightweight web framework for Python, where it's kind of you do all the really cool stuff in Python, and then you just you can actually call those functions from JavaScript on the client side, which is pretty fun. But the really cool thing is you can actually stream data as basically a Python generator back to the client side. So as new information comes in, we can just stream that up to the client side. So you can just have that website sitting there, and updates will happen as they happen. And you don't have to ping the server or anything like that. Okay, I'm just about out of time. But this is, okay, write a regular Python module, start the server, call your function from JavaScript, and there you go. You're now calling Python functions from the client side, which is pretty fun. And here's this sort of how you do it to stream it back. So I have one more minute. Where are we at now? I don't have a live demo to show you because my collaborator, he went and got married and got a real job. So the product is not quite where it's supposed to be right now. So the science works, but the sort of production-ready version is not ready yet. But the really cool thing is how lightweight this thing is. If you can pip install something, then you can run it on your server, any server. No big storage requirements, no super powerful analytics frameworks, nothing. Just if you can pip install SciPy, then you're good to go. You can do all this on any server. So that's kind of the coolest thing about it. Right, so what we learned was people tweet about themselves a lot. That's why the stop words are important. You got to get rid of like me, my, I, I'm, they, we, and lol and things like that. So stop words were very important. Otherwise, all the topics are I'm doing this. Anyway, if you have any more questions about it, come see me. Thanks very much.
Questions?
I can probably hear you.
So it seems like you could adapt this pretty easily if you're interested in one particular topic.
Yes,
to
definitely.
aim it at that particular topic. So if you're a disaster manager, you could say, look for stuff about earthquakes or crime or whatever.
Yeah, you can actually take the whole topic modeling piece out of the puzzle, and the Twitter streaming part, you can just say, okay, look for hashtags about this particular topic, or using these keywords, and then you can do the exact same thing. So you don't have to do the topic analysis because you know what your topic is already. Yeah.
Other questions?
Okay. You said that you use Pico for the framework. Is it similar to like WebSockets and other things, or how does it work?
Yeah, so it's kind of magic as far as I'm concerned. So it uses G-event. If you want to do it in a streaming context, it uses G-event, which is WebSockets and stuff like that, to actually simulate like streaming. And so your callback on the JavaScript side will just run every time some new information comes. That's what it's doing. Yeah.
I apologize because I probably spaced out when you said it, but the data source, the streaming that you're taking, is that from the Twitter 1% feed, or?
Actually, if you filter on geolocation, and if it's small enough, you can pretty much get all the tweets for that particular location. So you don't worry about this 1% feed. You actually get all of them. Yeah. So if you do it for small urban area, you can get all the tweets that happen there. Yeah. I don't know if you're supposed to do that, but you can.
You are, and it is limited to 1%. If it ever goes above 1%, they cap it.
Right, but I think it's 1% for the planet.
Yes, it is 1%.
Yeah. So obviously, if you pick a small city, you're never going to get. Well, I don't know. If you picked New York, you might actually be able to get more than 1% of the tweets happening in the world, but.
Only about 1% are geolocated.
Yeah, that's the other thing. We're only using geolocated tweets, right? So you actually have to like purposely turn on geolocation on your Twitter app, and possibly people in this room do that, but not everybody does. Any other questions?
So your tokenizer, when you looked at it, ARC folks haven't actually. Your tokenizer, the ARC, I went and looked at it. The ARC folks haven't actually updated it in 2 years. Is that still an active project?
So that one is not being updated. Did you check out the Python one, though?
I went and looked at the Python. I didn't check the dates on it.
Yeah, so that one's being more actively updated, yeah. But also, if you email, so I don't know how often they're actually updating the GitHub site, but if you email the developer, he has more recent versions as well.
Okay, thank you.
Yeah.
So I guess this is kind of based on what you were just saying about the requirement that the user turns on geolocation. and I guess you, being a social scientist, might have more of a comment on it, but do you find then that the topics that you're discovering from this are just outrageously nerdy compared to the normal population? Or like, how well does this reflect what people are actually tweeting about if it's selected for nerds that go into the settings of their Twitter apps?
Yeah, I mean, with any of these, any data sources like this, it's not a representative sample of the overall population. I mean, first of all, you're already self-selecting for people who are using Twitter, period. And then you're self-selecting for people who are interested in sharing their geolocation. So you're getting some strange topics. Like, you know, going to SciPy, awesome, is probably more likely to happen than, you know, oh, I'm off to the ball or the debutante ball or something. I don't know. I don't know what people tweet about. But, you know, there's self-selection happening there. So yes, I would never use this as like the sole way to identify disaster events or something like that. Although I think if something terrible happened, people will tweet about it. Yeah, yeah.
Well, I think that's all of our time, so let's thank the speaker one more time.